Hi again, welcome to the day 3 of this series. In this assignment, we'll be learning how to make agents stateful by managing conversation history through context engineering in ADK. This is about context engineering sessions and memory, and we'll also have 2 code labs for this assignment as well. And we have a summary podcast episode and a relevant complement white paper, which is on context engineering sessions and memory. Let's quickly go to the part A of day 3, which is building our stateful agents and perform context engineering. Let's edit and get our editable copy. So what are we going to learn in this session? In the part 1, which is for day 3 part 1, we will learn what sessions are and how to use them in the agent, how to build stateful agents with sessions and events, and how to persist those sessions in a database, context management practices such as context compaction, and best practices for sharing the session state. As we know, we don't need to install the Google ADK library for Python. We'll be jumping to the configure Gemini API key section of the section 1. For that, we'll click on add-ons, secret, select the key, and run our code. We have done this successfully. Now we'll import the ADK components. Over here, we have the EventsCompactionConfig, which is a new addition in our exercise, DatabaseSessionService, and InMemorySessions tool context. We'll discuss an EventsCompactionConfig while reading the code. Great, we have now successfully imported the ADK components. The next section is to define the helper function. This helper function here manages a complete conversation session, handling session creation and retrieval, query processing, and response streaming. So it supports both single queries and multiple queries in sequence. If you have something like what is the capital of France and geography session, or you say hello, what's my name, and then you say user intro session. So let me just run this. It's done pretty quickly. We'll run the config, done, which means that an agent without proper context management will react to the current prompt without considering any previous history. So now we have completed the setup successfully. Let's jump to the next section, which is session management. Every LLM is inherently stateless, which means that the awareness is confined to the information you provide in a single API. That means agent without a proper context management will react to the current prompt without considering any previous history, any previous conversation that you had with them. Why is this a problem? Because in real world, imagine you are talking to someone, you're trying to have a meaningful conversation with someone, and that person keeps forgetting everything, every sentence that you have said just before what you're saying momentarily. That's the challenge we face with raw LLMs. Hence, we use sessions and memory. Sessions for short-term memory management and memory for long-term memory management. Now, here in this notebook, we'll focus on memory first. Before that, let's understand what's session. So session is a container of conversations. So it encapsulates the conversation history in a chronological manner and also records all tool interactions and responses for a single continuous conversation. A session is tied to a user and an agent. It is not shared with other users. Similarly, a session history for an agent is not shared with other agents. So in ADK, a session is comprised of 2 components, events and state. So let's understand what's event and state. For example, you have a user input, you have agent response, you have tool call, and you have tool output. These are all examples of event. You can call each of them an event. What is a state? So session state is the agent's scratch pad, where it stores and updates dynamic details needed during the conversation. You can think of it as a global key value paired storage, which is available to all sub-agents and tools. So this is how it works. So in this session, you have these 2 components, events and state. This is user, this is agent application. Now the next question is, how do we manage these sessions? An agentic application can have multiple users, and each user may have multiple sessions with the application. To manage these sessions and events, ADK offers a session manager and a runner. What does this session service do? This is basically the storage layer. It manages creation, storage, and retrieval of session data, and it also manages different implementations for different needs, and it has different implementations for different needs like memory, database, cloud, etc. A runner, as we all know, it's a core, it's an orchestration layer. It manages the flow of information between user and agent. It automatically maintains the conversation history. It handles the context engineering behind the scenes. So basically, it's like, a session is a notebook, events is like individual entries in a single page, service is the filing cabinet storing notebooks, and runner is the assistant managing the conversation. Now, let's implement our first stateful agent. Let me run this code first, and then we can go through this. So over here, we have got an app name, user ID, and session. The model that we are using is Gemini 2.5 Flashlight. The first step here is to create an LLM agent, and we know how we do it. And the description, it's a chatbot that we are creating. Second step is session management, in which we'll have a service. We'll define the session service as InMemorySessionService. Then we'll create a runner. That is basically, you have to have an agent, the app name, and the session service. We are printing all of this here. This is done. Now, the next step is to test our stateful agent. And in runner, we have asked two questions. One is, hi, I'm Sam. What is the capital of United States? Hello, what is my name? Now, once this is done, it can prompt. The agent should remember the name of Sam. So let's see how this happens. All right, so user prompt is, hi, I'm Sam. What is the capital of United States? Then the chatbot says, hi, Sam. The capital of United States is Washington, D.C. Second, the user is like, hello, what is my name? The chatbot has responded saying, your name is Sam. From this, we understand that the runner automatically maintained the conversation history. But one catch is that this in-memory service, session service, which is the session service, is temporary, as we have mentioned here, right? So you see, this stores conversations in RAM, which is like temporary. Hence, once the application stops, all conversation history is lost. Now let's test the forgetfulness of this agent. We'll try to verify agent forgets the conversation. We'll restart the kernel by running this. Then we'll run all the previous cells in this notebook except the run session, which is 2.5. Okay. So now we have done this, and it says, what did I ask you about earlier? You asked me about the capital of United States. And remind me, what's my name? Your name is Sam. Now I'm going back and I'm going to run all the previous cells. As in this one, done. And I will skip this part. Okay. And I'll directly come to this part. So here you see the response changed. What did I ask you about earlier? I'm sorry, I cannot recall past conversations. I do not have memory of our previous interactions. And remind me, what's my name? I do not have access to your personal information, including your name. I'm a text chatbot and do not store any data about users. Hence, you see that we skipped this part. We have run this and we directly jumped to the next runner session. It forgot what we discussed here. So, which means that every time you reset the application, you restart the kernel, the history is vanished. Now, this is a problem, right? Because if the session information is not persistent, this doesn't help in the real world. A user should be able to refer from the past and resume the conversations. Hence, to achieve this, we will go to the next section, which is persistent sessions with DatabaseSessionService. If you remember, we have imported this service already. Now, the first step is to choose the right session service. ADK provides different session service implementations for different needs. Alright, so first is in-memory service session service, which is for development and testing. And this is lost on restart, and this is the code that we have used in our previous code. Next is database session. It's a self-managed app. It survives restart, which means it will not lose the history. Third is agent engine sessions. It's production on GCP. It's fully managed. It's an enterprise scale. So for now, because we are in sandbox, we are in demo, we will be going with database session service. Now let's upgrade to this using the SQLite. This gives us persistence without needing a separate database server for this demo. We'll create the chatbot, which is capable of having a conversation with the user, something like ChatGPT or Gemini. Now we are defining the agent. We have got the name, we have got the description saying a chatbot with persistent memory. Now we are switched to database services, and we will create a SQLite database automatically. So we have got the DB URL, which is a local file, and we have the session service. We have replaced the in-memory one with database session service. Now we will run the runner. This is done successfully. It's upgraded. Now we'll verify persistence, which means we will first run this. Now it says, "Hi, I'm Sam. What is the capital of United States?" We have asked the same question and it has given us the same answers. Over here, we have the session ID, which is 01. Okay. Now let's verify if this session is isolated or not. So this is session. What is my name? I do not have access to personal information, including your name. Therefore, I cannot tell you what your name is. This means that a session is a private session between agent and user. In two sessions, you do not share information. So you run this session with a different session ID. As you see 02, and this was 01. It will say, "I do not know your name." Next section is the context compaction. In this, we see that all the events here are stored in full in the session database and quickly adds up. So for a long complex task, this list can become very large, leading to slower performance and higher cost. But if you could automatically summarize the past, let's use the context compaction feature to see how automatically reduce the context that's stored in this session. For that, we'll create an app for the agent. We'll use the same chatbot that we have used in the previous session, and the first step is to create an object called app, and then we will create a new config to do the context compaction. And this config is basically EventsCompactionConfig. It has two key variables. One is interval and another is overlap size. And the interval is basically ask the runner to compact the history after XYZ conversations, like so that it becomes smaller. Then the overlap size, it defines the number of previous conversations to retain for overlap. Now we'll provide this app to the runner. We'll first define the app here. This is the app, the agent. We have got the new part here, which is events compaction. This is a config, the interval and the overlap, which we've mentioned. So we have given the 3 intervals here, which means trigger compaction every 3 invocations. Overlap size is 1, which means keep one previous turn for context. We are giving a DB URL session service, and we are creating a new runner for our upgraded app. Research runner compacting runner, and app is research app compacting session service equal to session service. We'll run this code. So you see research app upgraded with events compaction. We have got this answer. We have got this print statement. Now we'll turn 1. We'll run the demo and see how it works. Let's have a long conversation like we have turn 1, turn 2, turn 3, and turn 4, which means that this is long to trigger the compaction. And when we run this code snippet, the output should look like a normal conversation because we configured our app. A compaction process will run silently in the background after the 3rd invocation. Let me just run this. This is now done, and you see the compaction demo. You have the entire conversation. The first question was, what's the latest news about AI in healthcare? So it has given us that. And the next is about, are there any new developments in drug discovery? Are there any new developments in drug? So you see it's giving us very lengthy and nice answers. Then comes next one. So if you see it keep on going, and you have all the conversation here. Now we'll verify the compaction in the session history, right? Which means that this conversation looks normal, but the history has changed behind the scenes. Let's see how that has happened. So we'll run this. We can inspect events in our session, and the compaction process does not delete old events. It replaces them with a single new event that contains the summary. So let's find. So over here it says found the compaction event author, and it tells you what exactly has happened here. You can go through this. It will say with the second one, and it talks about the AI here, right? And yeah, you have to just go through this, and you will find out that the author and compacted information is provided, the summary. Now, what you have accomplished? That's something that we need to know. So let's quickly recap. We have done a silent operation, which means we ran a standard conversation, and from the outside, nothing seemed different, looked like a normal conversation to us. Whereas in the background, we configured the app with events compact config, and the ADK runner automatically monitored the conversation length. Once the threshold was met, it triggered the summarization process in the background. After that, we did verify the result. We inspected the session event, and we found that the summary that the LLM generated, this summary now replaces the old and more verbose turns in the agent's active context. Next is section is more context engineering options in ADK. One is compact. Next is caching. So custom compact basically means it's for more advanced use cases. You can provide your own by defining a custom sliding window compactor and passing it to the config. What happens with this is it allows you to control the summarization prompt or even use a different specialized LLM for the task. You can read more about it in the official documentation here. Next is context caching, which means that ADK also provides this caching to help reduce the token size of the static instructions that are fed to the LLM by caching the request data. You can read more about it in the link here. I'll be putting all of these in the description. Over here, we'll be talking about session state. So how a session state management is created. So the first subsection here is creating custom tools for session state management. We'll here manually manage session state through custom tools. In this example that we are going to demo, we'll identify transferable characteristics like username, their country, and create tools to capture and save it. Why are we using this example? Username is a perfect example of information that is introduced once but referenced multiple times, right? Then it should persist throughout the conversation because it represents a user-specific characteristic that enhances personalization. So here for the demo purpose, we'll create two tools that can store and retrieve username and country from the session state. So note all tools have access to the tool context object that we had imported in the beginning while creating this notebook. Now you do not have to create a separate tools for each piece of information you want to share. You can have it everything here. So the username scope level is temp, user, and app. This is the best practice. Basically, this is what you're following. Then we'll define the user info. You have a tool context string, country is also string. Now in the argument we are saying that username is stored in session state and country is the name of user's country. We are writing the session state here, tool context, username, and country. We'll return the status as success. Next step is to understand how to read the tool from this state. We are retrieving the information. Over here we saved the information and now we are retrieving the information. So here tool to retrieve username and country from session. Username, we'll be taking it from this session state and country here. So if you don't have it, it says country not found, username not found. Otherwise it will return a success state with username and country. Let's create the tool, running the snippet. This is done. Now, next step is to create an agent for the session tool. So we have app user ID model. The agent is again text chatbot. Description is tools for managing user context to record username and country when provided. Use save user info to fetch, use retrieve user info. Okay, now the tools are as usual user and retrieve. We'll set up the session service and runner. Over here we are going to run this. Agent with session state tools initialized. Now we'll test the session state. The prompt here is, hi there, how are you doing today? What is my name? Then it says my name is Sam, I'm from Poland. And then again it asks what is my name, which country I'm from. So it says hello there, how are you doing today? What's my name? It says hi, hello, I'm doing well, thank you for asking. I can't remember your name as I don't have access to past conversations. If you would like me to remember it, please tell me your name and country. Now it says my name is and I'm from Poland. It responds saying that I have saved your name as Sam and your country as Poland. How can I help you further? So now we again ask the same question. It says your name is Sam and you are from Poland. Now let's inspect the session state. So in the session state you have username as Sam and country as Poland. This is how it has been fed. Next, let's isolate it. So now we isolate it. So this is a new isolated session and we have asked the same question again. And this person says that I'm not sure what your name is, though can you tell me? Which means that the agent won't know the name because this is a different session now. Now let's do a cross-session state sharing. I'm running this snippet and this snippet is basically saying that you have a new session and the session state is a state of previous session. Hence it gives in the new state the name and the country. Now we'll clean up the existing database and we'll start fresh. So the database has been cleaned up. So cleaned up old data files. Hence, in summary, we now know what's context engineering, session and events, persistent storage, session state, manual state management, production consideration. Let's now go to the next video, which is part 2 of day 3, where we will run the code lab about long-term memory systems. Thank you.